Hello everyone, and welcome to week 2 of my course. In this lecture, we will study petroleum geology, which is one of the most important foundations of petroleum engineering. Before we can explore for oil and gas, produce them, or even store carbon dioxide underground, we need to understand the geology of the subsurface. This week will help you understand how rocks form, how petroleum systems develop, and why geology is essential for both hydrocarbon production and carbon storage. Before we begin, let us quickly see where week 2 fits into the overall course. In week 1, we discussed the fundamentals of petroleum engineering and introduced petroleum and carbon capture and storage. In week 2, we move into petroleum geology. After this, we will continue with geophysical methods, drilling, petrophysics, well logging, reservoir engineering, production topics, and finally the role of CCS for future petroleum engineers. So this lecture is a key bridge between general introduction and more technical petroleum engineering topics. This week is organized into several major parts. First, we will discuss basic geology. Then we will study rock types and the rock cycle. After that, we move to basic petroleum geology, followed by types of hydrocarbon reservoirs. Finally, we will connect petroleum geology with CCS, and close with recap and key learnings. I want you to think of this lecture as a story. We begin with rocks, then move to petroleum systems, then to reservoir fluids, and finally to modern energy application. Let's start with a fun question. This image says fossil and deep underground. What does it make you think about? For many people, this immediately brings to mind fossil fuels, oil, gas, and coal. The purpose of this slide is to remind us that petroleum is not randomly created. It comes from ancient organic material that was buried deep underground and transformed over geological time. So even though this is a fun opening slide, it already points to the central idea of petroleum geology. Petroleum has a geological origin. Now let us begin with the basics. Geology is the study of the origin, history, and structure of the solid earth. Petroleum occurrence is intrinsically associated with rocks, especially reservoir rocks, so to understand petroleum, we must first understand geology. This slide asks 3 important questions. What is geology? Why do we need to know basic geology? And what does the inside of the earth look like? These questions may sound broad, but they are essential because petroleum engineering always begins with the subsurface. This slide shows the internal structure of the earth, the crust, upper mantle, lower mantle, outer core, and inner core. Of course, petroleum reservoirs occur only in the shallow part of the crust, but it is useful to remember that the Earth is a layered dynamic system. Geologists study Earth processes at many scales, from plate tectonics and mantle interactions at the planetary scale, all the way down to grain scale and pore scale processes, such as cementation between sand grains or swelling of clays in pores. This multi-scale perspective is very important in petroleum geology because a reservoir can be influenced both by regional tectonics and by pore-scale rock properties. This slide asks an important question. Which type of rock is most associated with the formation of petroleum, and how does it contribute? The answer is mainly sedimentary rocks. Sedimentary rocks are formed by the accumulation of minerals and organic matter. They can be clastic, carbonate, or evaporitic. Petroleum is closely linked to sedimentary basins because organic material is deposited, buried, and transformed there over long geological time. Rocks such as sandstone and limestone are especially important because they often serve as good reservoir rocks for petroleum and natural gas. This is a fun comparison: cake layer versus rock layer. Pause. Why do I include this slide? Because it helps students visualize layering, or stratification. Just as a cake can have multiple visible layers stacked one above another, sedimentary rocks are also deposited in layers over time. Of course, geology is much more complex than cake, but this simple analogy helps you remember that sedimentary formations are built in sequences, and those sequences are very important for understanding petroleum systems. Now let us move to the rock cycle. The rock cycle describes how rocks transform between igneous, sedimentary, and metamorphic types over geological time. Igneous rocks form from cooling magma, sedimentary rocks form from deposited sediments, and metamorphic rocks form when pre-existing rocks are altered by heat and pressure. For petroleum geology, the most important part is the development of sedimentary basins, because these are the environments where organic matter can accumulate, become buried, and eventually form hydrocarbons.